Good morning, dear students. Good morning, all of you. How are you all? Fine. Okay. So this is a video of class 10, and in this video we are going to discuss about the conceptual questions. And the very first question you can see, you have to write the name of the element which contains which have two cells, and both of which are completely filled with electrons. So you should understand this question, that if any of the element is there, and this elements which contains two cell, that means K cell and L cell. Okay na? K and L, both cell would be there. In the very first cell, the maximum number of electrons should be 2. Okay, and then after, in the second cell, the maximum number of electrons should be 8. And both of the cell have completely, you can see, which are completely filled, both of the cells which are completely filled with the electrons. So 2 in the first cell and 8 in the last cell, so together it makes 10, and 10 is the atomic number of neon. So the correct answer is neon. Okay now the next question you can see, the electronic configuration 282, and if you will add all these electrons from the first cell, from the second cell K 2, then L 8, then 2, so 2 plus 8 plus 2, and that one will give you 12. So the atomic number, and that one is 12, so that one is magnesium, which has atomic number 12. A total of three cells, that means K, L, M, three cells are there with 4 electrons in its valence cell. 4 electron in its valence cell, that means M is having 4 electron. M is 4, that means the rest are fully occupied. So in the first cell 2 electron is there, second cell 8 electron is there, and in the fourth one, okay, in the M cell 4 electrons were there. So 2 plus 8 plus 4, 14, and together it makes the electronic configuration of silicon. Okay na? So that you can understand. Now next one, a total of two cells means K and L, with 3 electron in its valence cell, 3 electrons. So in the first cell 2, and in the second cell 3, so 2 plus 3 5, and that must be boron electronic configuration. Okay now, and here you can see twice as many electrons in its second cell as in its first cell. Twice as many means in the first cell there would be 2 electrons, and in the second cell twice, so 2 into 2 4. Okay now, so that one would be the carbon. Okay dear students, now you can see here the next question is, what was the basis of Mendeleev's classification of elements? We have discussed many times in the class that basis of the classification of the Mendeleev's periodic table was the atomic mass. Means we can say, whenever we are actually arranging the elements on the basis of their increased atomic mass, in the order of increasing atomic mass, the elements with similar properties reoccur at a regular interval of time. This you have done in that the Mendeleev's classification of elements, when the elements are arranged in order of increasing atomic mass. So the basis of classification is atomic mass, not atomic number. Okay dear students, so whenever you will arrange the elements in the basis of using atomic mass, after some interval of time you will find that the similar properties will definitely repeat. Okay now the next one, why do all the elements in a group of the modern periodic table have similar chemical properties. Why do all the elements in a group of the modern periodic table have similar chemical properties? Modern periodic table they are talking about. You can see the answer is there. Modern periodic table, if I am talking about here, we will take one of the group and then we will try to understand. Lithium, sodium, potassium, rubidium, cesium and francium. Okay, so if I will write the electronic configuration to 1 2 8 1 2 8 8 1 means valence electrons everywhere. If I will write for rubidium also, cesium also, francium also, if I will write the electrons number, then 1 is coming as a valence electron. Okay na? So if the valence electron is same, that means they can lose one electron. They can lose one electron, that means they will carry one positive charge, one positive charge everywhere. So it will actually combine with the anion and it will form their respective same type of compound. As one lithium is forming, sodium will also form the same, potassium will also form the same. So what is the reason? What is the reason? You can see, you can read that one. All the elements of a group of the modern periodic table have similar chemical properties because they have the same number of valence electrons in the outermost shell. Okay na? Now you can see calcium, strontium and barium form a Daubernier stride. Daubernier strides were the set of three elements, a group of three elements, okay, where the first atoms and the third atom's average atomic mass was equal or nearly equal to the second atom's atomic mass. This you have done in the class. Calcium, strontium and barium forms a Daubernier strides. The atomic masses of calcium and barium are 40 and 137 respectively. Predict the atomic mass of strontium. So you can see here we will solve this question. Calcium, strontium, barium, calcium atomic mass 40, barium atomic mass 137. You have to calculate this one. Question mark, this you have to calculate. How will you calculate that one? So we have discussed average atomic mass of this first one and third one. Okay na? So 40 plus 137 divided by 2, it will give you 177 by 2. So 771. Okay, so it will give you 88.5. And you know, dear student, if I am talking about the strontium atomic mass is 88. So yes, strontium, after calculation we can say it is nearly equal, not 88 exactly, but it is nearly equal. So we will say that strontium, calcium and barium will come in the similar group. Okay na? You can write, instead of this one you can write like this one. Okay na? 40 plus 137 upon 2, 177 upon 2, so 88.5 it will give you. Okay dear students, now you can see the two isotopes of chlorine have atomic mass 35.4 and 37.4. Should they be placed in separate slots in the modern periodic table? This is very simple question. As we all know that modern periodic table, the basis of the modern periodic table was atomic number, not the atomic mass. So this is not the correct question. Not a correct question. That means atomic mass was not the basis of classification. So here you can say no, they should be placed in the same slot because a modern periodic table is based on the atomic number of the element and not on the atomic masses. So this you can understand. Okay, thank you.